Mined diamonds are no longer the only option. Today's market offers a wide selection of stones, from lab-grown diamonds to diamond alternatives. Now, let's dive into the video and know more about the manufacturing process of diamonds. Everyone is created differently and therefore can have different qualities. Physical properties, optical brilliance, price, and origin are the most common differences between these stones. Before you buy a fine diamond engagement ring or jewelry, find out what distinguishes the three most common diamonds and diamond alternatives. Mined natural diamonds are crystallized carbon structures that formed under perfect conditions of heat and pressure beneath the Earth's surface over millions of years. Diamonds are brought to the surface during natural events and then mined from land. By now, you've probably heard that the diamonds that are mined come from a very dark place, and we're not talking about Earth. The diamonds mined cost the mining company between 88,000 to 176,000 pounds of land. Pollution caused by diamond mines destroys marine habitat and can even cause acid rock waste to flow into groundwater and contaminate all living things that depend on water sources. This industry is known for the inhumane treatment of workers and even child labor, not to mention the higher risk of health problems. Another interesting fact about mined diamonds is that they were not a popular commodity for engagement rings until the early 1900s, when the De Beers Diamond Corporation first ran the Diamond is Forever campaign.
How else could 2 months' salary last forever? A diamond is forever. De Beers.
This campaign is known as one of the most successful campaigns because it creates demand in a market where it doesn't exist. This psychological need is still practiced by most couples today. Let's dig deeper into the details of making natural diamonds. Diamonds form naturally within the Earth's mantle under extreme conditions of temperature and pressure. These conditions occur in an enclosed area about 100 miles or more below the surface, where temperatures are at least 2,000 degrees Fahrenheit, and pressures are at or above 725,000 pounds per square inch. These are the critical temperatures and pressures required for the formation and stability of natural diamonds. The carbon atoms then combine in the extreme environment and form diamonds. Diamonds that are formed and deposited in these confined areas of the Earth's depths are brought to the surface by volcanic eruptions. This eruption ripped part of the upper mantle and brought it to the surface. Only volcanoes erupting from great depths would cause this. The average volcano would not. Are lab diamonds real? Yes, lab diamonds are the same as mined diamonds, except they're grown in a lab rather than mined deep in the earth. They consist of a crystallized carbon structure, meaning they have the same chemical, physical, and optical properties as mined diamonds. Lab diamonds are created under the same conditions as mined diamonds, so each diamond is very different. Hence, they're classified under the same 4C diamond quality. This grading system assesses the overall quality of the stone, which determines how much a diamond is worth. Lab diamonds are grown from carbon seeds, like flowers in a greenhouse. As technology has advanced rapidly, scientists have been able to reproduce the conditions under which diamonds form naturally using two main methods: chemical vapor deposition and high pressure and high temperature. Humans can make artificial diamonds or lab-grown diamond stimulants. A newer and more adaptive process is chemical vapor precipitation. In the diamond CVD process, small discs filled with diamond seeds are placed in a chamber and heated to extreme temperatures, much like a rough diamond in the ground. The chamber is then filled with gases that help form diamonds, such as methane. The gas is ionized with a laser to form plasma. Ionization breaks the molecular bonds, and the carbon attaches to the diamond core and slowly crystallizes. The result is a crystallized carbon structure very similar to that of mined diamonds. The HPHT diamond process is still widely used and produces the same products. This process uses one of three manufacturing processes: belt press, Q press, and split sphere press. The three processes create a high-pressure, high-temperature environment. In this process, the diamond seed is placed in carbon. Using one of the three methods, it is then subjected to a temperature of about 2,000 degrees Fahrenheit and a pressure of about 1.5 million pounds per square inch. The carbon melts and begins to form a diamond core. After the cooling process is complete, The result is a crystallized carbon structure. An alternative to diamonds is simulated stones that look like diamonds but are chemically different. There are many options on the market today, such as cubic zirconia, morganite, and amethyst. Each stone has very different properties because it is made of different materials. Cubic zirconia is one of the most widely available diamond alternatives on the market, often found in inexpensive jewelry. While well-cut cubic zirconia may appear similar to a diamond at first glance, it is much more porous than a diamond, allowing it to absorb contaminants and dull them over time. The leading diamond alternative on the market is the Nexus Diamond alternative, which most closely resembles the look, feel, and flawless wear of mined diamonds, with two exceptions. They're much cheaper and perfect in every way. Nexus diamonds are made from a proprietary formula and coating materials that cause them to reflect light closer to the diamonds than any other imitation. The end product is a stone that is harder, heavier, and less porous than alternative stones, making it more like a flawless diamond. The process of making imitation diamonds begins much like the process of diamonds in a laboratory. A proprietary element mixture is heated to extreme temperatures. The elements then reach a liquid state. The next step is to cool the liquid matrix carefully in controlled steps to allow crystals to form. This is one of the most critical stages of a diamond making simulator. If cooled too slowly, crystals will not form. If it cools too quickly, the crystals will break. After the cooling step, what remains is a solid containing both crystallized and uncrystallized materials. Crystal is a hard, heavy, and dense material that closely resembles the appearance of uncut diamond crystals. Crystals are checked for quality in the same way as rough diamonds are checked and graded according to the 4C. Once the stones are rough cut, they are free of inclusions or other imperfections. They're stored and fed to the final cutting stage. Since every crystal is flawless, our master cutters can be much more precise because they spend less effort on cutting and hiding defects. This means that all of our diamond stimulants are cut to ideal standards and produce the desired heart and arrow effect found in the finest diamonds on the diamond scale. Our diamond stimulants are then coated with a proprietary coating agent that seals them completely, making them even harder and less porous. Plating completes the diamond imitation process. Diamond cutters have long understood good diamond design through trial and error. In 1919, Marcel Tokowski published the first scientific paper on diamond cutting, explaining why certain proportions would produce the greatest brilliance and fire. His work is based on mathematics applied to the known behavior of light when reflected and refracted by diamonds. Modern science has given us a much better understanding of the light efficiency of diamonds, leading to the publication of the first light grading system by the Gemological Society of America in 2005. For diamonds to form, a carbon source must be available and a relatively narrow range of moderate temperatures and pressures must be balanced. This occurs about 100 miles beneath the Earth's crust. Once crystallized, the diamond must be transferred